if we want our f of x to be x squared plus 2, let's try that again, x squared plus 2 on the interval from negative 2 to 0, then we want to use the intermediate value theorem to say that our w equals 3, or our f of c equals 3, and find the values of c that are guaranteed by the theorem. So if we remember, intermediate value theorem states that f of a is less than to f of c is less than to f of b, or f of b is less than our f of c is less than our f of a, then there exists a c that is between our a and our b, between our a and our b. So what does this look like in a graph? If we graph our function, give little hats on these things. So if we graph our function, it's going to be a parabola that's been shifted, and we have our f of a and our f of b. So our a is going to be, so we have the interval negative 2 comma 0, and that's going to be our a and b. So if our a is negative 2, this is our a value. Our b is 0, our b value. Then our f of a is going to be whatever function value negative 2. So what is f of a? F of a is equal to negative 2 squared plus 2, which equals 6. So if we plot that, 1, 2, 3, 4, 5, 6, we have like 6 up here. This is our f of a value. And then our b value, our f of b, if we come over here, find out our f of b, which is going to be 0 squared plus 2, which is 2. So then if we plot that, so we now have our f of a, our f of b, we have our a and our b terms. So if we come back to intermediate value theorem, we have, if our f of c is between our f of a and our f of b, then there has to be a c value between our a and our b. So if we come back to f of c, which equals 3, so it's saying is our f of c, which is 3, so our function value at 3 is this value between our a and our b. Yes, so 3 is on our interval because 3 is between 2 and 6. This is our f of b is less than our f of c, which is less than our f of a. Oh gosh, f of a. So now that our f of c is between f of b and f of a, that means there has to be a c value between b and a. So if we draw out our function here, so f of c is equal to 3, that means c squared plus 2 is equal to 3, so c squared plus 2 is equal to 3, so c squared is equal to 1, c is equal to square root of 1, so c is equal to negative 1 comma 1. So now we found our c value, but c needs to be between a and b. So if we come back to our graph, we have our c value of 1, our c value of negative 1, but there's only one value that's between our a and b, and that's negative 1. So using the intermediate value theorem, we found that our function's value f of c is between our f of a and our f of b. Then we found our c value that's between our a and our b, and that c value is negative 1.